All right, you're going to be asked to find the limit as, just kind of paying attention to what's going on here, as delta x, not x, but delta x, because we have both going on in the problem. Find the limit as delta x approaches 0 of this expression. This is going to be called a difference quotient in the future, but right now I just want to kind of look at this right now with you. Okay, let's find this limit for the next two examples. Well, before we do, so consider this like our formula. Let's first of all go ahead and evaluate this expression at 0. So if I substitute in 0 for delta x, notice I get f of x minus another f of x, which is 0. Okay, down here I get 0, 0 over 0, which is indeterminate. So what that tells us, like in the previous examples, is that if we don't have a graphing calculator, we want to have some other kind of option for finding the value of the limit. Okay, so this is like our formula. I want you to kind of consider that being on hold for just a minute. And you actually did something like this in pre-cal last year, but I think often we used x plus h here, and this was h in the denominator as well right here. So we were just getting you ready for calculus. Okay, so, and again, this has some kind of important implications for calculus, but right now let's just kind of work through the mechanics of using this formula, for example, 4 and 5. All right, so what we're going to need to do here is this. If you notice in the numerator, here's the function itself that was given over here in problem 4. I'm going to actually replace in 3x minus 5 here for this function. Of course, I'm going to put parentheses around that. Because I'm going to need to perform some calculations with f of x, and this is function notation, and right now I can't perform calculations with just notation. Okay, notice also that I need f, the function itself, evaluated at the input x plus delta x, and you have a little experience with this last year. So what we're going to do here is we're going to build an expression, okay, for f evaluated at x plus delta x. All right, so this is my input, just like this is my input x. So if I see x here as an input, that means x is going to be present here. Well, my input is x plus delta x. It's no different than if this was a number. If this was just a specific number, I'd be evaluating in this x right here, that specific number. So I'm going to do the same thing with this expression. Where x is, I'm going to replace it with this input. So everything's the same here, okay, except for the expression x plus delta x was substituted in here. So now I have what I need, if you will, these two expressions right here to substitute into the numerator. So these were the difference quotients that you guys looked at last year, knowing that we needed to revisit it this year. Okay, so what I'm going to do is consider this my formula, and I'm going to come down here with some working space. Don't know what just happened there. Okay, and right here in the numerator, we're going to replace in, oh goodness, I don't know really what happened. Okay, I'm going to replace in the numerator right here these two expressions. I'm actually going to subtract these two expressions because it's this expression minus this expression, but what they're equal to are these two things right here. So okay, so all of this is equivalent to this notation here, minus, but instead of f of x, I'm going to put in 3x minus 5. And notice it's important to use parentheses because I'm going to have to distribute that negative sign through and change the sign of both terms. You wouldn't want to leave off the parentheses because then the sign wouldn't match up here. And then I have delta x. Okay. All right, kind of pause here, catch your breath, look at what's going on. Notice that if I were to try and plug in 0 for delta x being a change in x is what that means. If I plugged in 0 for delta x, not x, okay, that would go to 0. I'd have 3x minus 5 minus another 3x minus 5. Again, a 0 in the numerator and a 0 in the bottom. So we'd have indeterminate. So what do? The necessary algebra. Oh, that should be delta x. Oh, nice. Cleaning up the numerator, I think this is supposed to be a minus. Cleaning up the numerator, you see that you can cancel your linear terms. You can cancel, oh, I need to change the sign, my bad. Okay, you can change, cancel the constant terms, and you're left with, let's clean this up, 3 delta x here over a delta x in the denominator. Oops, trying to fix this. See if I can shorten it. Okay. Okay, now that I've messed that up completely. All right. Just trying to give myself some more room here. Okay, notice where we're at now. I can divide out delta x with the delta x, and I'm actually left with the limit as delta x approaches 0 of 3, which is equal to 3. So think of this as 3r divided by an r. And your r's would cancel and you'd be left with 3. So our limit here in this case is 3. Okay, let's look at example 5. Same thing too. We're going to use the same formula, but now the new function 3 over x as opposed to this linear function here. So what I'm going to do is I'm going to come over here and build what I need. Notice that I have 3 over x, but what I need is the replacement with x plus delta x. So let's evaluate the function at that new input. So that just means everywhere I see x, replace it with x plus delta x. All right. Okay, so coming over here, using the formula. Okay, it's f evaluated at x plus delta x minus the function f of x, coming over here, stealing that, all the I don't know what that does. There. Okay. Okay, when we study this right here and we evaluate this limit when delta x is 0, again, notice if that goes to 0, we have 3 over x minus itself, 0 over 0, indeterminate. So what do we do from here? Well, there's not an obvious factoring thing. There's not an obvious algebra thing to do here. You know, I don't see conjugates working. You can try. It's going to get ugly. Okay, if you see rational expressions, you might want to think about clearing this complex fraction. Okay, so in that case, what I mean, let's revisit some algebra 2. This is a complex fraction. So what I'm going to do is I am going to think about what the common denominator is with all these different denominators. So I'm going to put delta x over 1. So thinking about x plus delta x, thinking about x, thinking about 1, all the denominators, I'm going to build an expression, okay, with those factors in it. So I'm going to multiply every term in this complex fraction by the product x plus delta x. And I'm going to put this over 1. And remember, in a fraction, you want to multiply by a clever form of 1, retain the value. So down here, I'm going to put x times quantity x plus delta x. Okay, so if you have a complex fraction, you might want to think about the algebraic technique of clearing the expression of fractions. Okay, so I'm going to come down here and clean it up. Oh, goodness. Okay, if I were to multiply now, what I need to do is take this clever form of 1 and distribute it with all the terms here. Okay. Notice when I multiply these two expressions together, the x plus delta x factors cancel, leaving the x factor to multiply by 3. So my numerator becomes 3x minus. Now this product, the x factors would cancel, leaving me to multiply 3 times quantity x plus delta x. We'll distribute next. Notice the denominator right here. I'm just going to kind of rearrange. I'm going to leave all factors alone. I'm not going to distribute. Okay, so I just end up with that factored form of the denominator. And for a reason, if you think about it for just a minute, what we're about to do. Okay, trying to save space. I see I'm getting kind of crowded here. Let me distribute the numerator. Okay, maybe you guys can see it. What's causing us problems is the delta x in the denominator. That's creating that division by 0. We want to certainly eliminate that. So these will cancel. Okay, notice what's left in the numerator. Okay. I have a negative 3 delta x. So I'm going to cancel out the factor of delta x and delta x because this is all in factored form and I can cancel those. Okay, kind of cleaning this up. It's going to get crowded because it doesn't like it close. I think this was supposed to be delta x approaches 0. Okay, so the cleanup on this is going to have us with negative 3 in the numerator, x still in the denominator, and quantity x plus delta x in the denominator. Now try evaluating at 0 when delta x goes to 0. And we're going to be left with negative 3 over, this will go to 0, x times x, or x squared.